Hello everyone, welcome to this video. I hope you're all doing great. Huh? सब बढ़िया चल रहा है. So we have started with algebra. In the previous video, we did polynomials, right? And the questions were brilliant. I loved it, and I hope you enjoyed the format of two single correct, two multi-correct, and two subjective questions. And I hope you did the homework. Let me know in the comments. The question was not really that tough. Today also probably I'll give the last question as homework, but I think I'll do it. I'll do it. The last question is a bit tricky one today. So let's get started, I guess, without any delay. All right, let's begin with the first question. Two roots of this equation are 1 and 2. This is a degree 4 equation. It has four roots, and two of them are 1 and 2. The other roots are what? We have to find it based on the given coefficients. This is basically root coefficient thing. So let's say alpha and beta. Okay, not alpha 1, just alpha and beta are the other roots. Okay. Oh, I should give you time. Okay, fine. Find alpha and beta. This is a single correct, so it is, obvious. So pause the video, try it. I hope you have done that. So alpha plus beta plus 1 plus 2, the sum of all the roots is equal to 8. Alpha into beta into 1 into 2 is equal to 12. So what do we have? Alpha plus beta is equal to 8 minus 3, 5. And alpha beta is equal to 6. All right. So now, after this happens, we can see that alpha and beta are roots of x square minus, or maybe instead of x, I'll use t square minus 5t plus 6 equal to 0, right? And obviously, we can see that this can be factored into t minus 2 into t minus 3. So that implies alpha equal to 2, beta equal to 3, something like this. Yeah. So 2 and 3 are the other two roots. That's a beautiful question. Yeah, relating biquadratic and quadratic. Very nice. Okay. What do we have here? Suppose u, v, w are the roots of this cubic equation. Very good. 1 by v, 1 by u, 1 by v, 1 by w are the roots of this. Okay, that should be an easy question, I think. You see, just try it, pause the video and try it. And I think this is a very easy question. If alpha is root of p of x equal to 0, then 1 by alpha is root of, if the degree is n, then x power n p of 1 by x, to make it a, what do you say, to make it a polynomial, I have to multiply x power n equal to 0. Do you see that happening? Can you see that happening? It will have denominator at most, denominator power at most n, and this will nullify that. So this is true. So if I have this as my p of x, what is p of 1 by x? That will be 1 by x cube plus 20 by x square plus 13 by x plus 42. Now that will imply x cube into p of 1 by x is 1 plus 20x plus 13 x square plus 42x cube, right? So 1 by u, 1 by v, 1 by w are roots of the following equation: 42x cube plus 13x square plus 20x plus 1 equal to 0. But we want the leading coefficient to be 1. So it will be roots of some q of x equal to x cube plus 13 by 42 x square plus 20, I don't know, 20 by 42 x. Does something cancel out? If you multiply with the 4, nope, nothing. plus 1 by 42 equal to 0. So you'll see that we want what? We want sum of all the coefficients. So it is easy. We want Q of 1. Q of 1 will be, array, piche wala question. Q of 1 will be 1 plus 13 by 42 plus 20 by 42 plus 1 by 42. So 13 plus, so this is 42 plus 13 plus 20, 33 plus 1, 34 by 42. So whatever this is, I think you can cancel stuff out from here. I think 2 will get cancelled out, 21, 21, 17. So 38 by 21, something like that. So yeah, got it? So I hope you understood all this. Very easy. This is multi-correct. It's a very good question again. Beautiful, lovely. Yeah, it uses triangle inequality at most. So use this. Pause the video, try this question. And I'm not going to wait till you pause the video. So A, B, let them be real numbers such that both the roots of the equation are real and have absolute value less than 1. So alpha and beta are the roots such that mod alpha mod beta is less than 1. So immediately, what can we say about the sum or product? Product we can say mod alpha into mod beta is mod alpha beta. And what is mod alpha beta? Alpha beta is minus b, you see, mod minus b. And this also has to be less than 1 because this is less than 1 because this is less than 1, less than 1. So that's it. B, mod b is less than 1. So option A is definitely correct. When do we get A? So what is A? A is alpha plus beta. Mod A is mod alpha plus beta. And by triangle inequality, this is always less than or equal to mod alpha plus mod beta. And both are strictly less than 1. So it is strictly less than 1 plus 1, which is 2. So mod A is less than 2. This is also correct. So sum and product, we got that. Very good. Now what do we want? We want to find what is A plus B. You see, for this, I would like to invoke a graph of a quadratic. You see, both the roots are alpha and beta roots. Both roots alpha and beta are such that mod alpha, mod beta is less than 1, right? So what do you understand by that in terms of graph? Alpha and beta are between -1 and 1. No? Both may be positive, both may be negative, one of them negative, one of them positive, whatever the case be, both will be between -1 and 1. Right? And the leading coefficient is positive, which is 1. So if I imagine the graph would be something like this. So do you see that if you say this is P of X, let's say this is P of X, do you see that P of 1 is positive and P of -1 is also positive, right? Yeah, you understand? Why? Because of the graph. P of 1 is here, P of -1 is here. May not be symmetric, it's just the diagram, but I hope you understand this. So what does that mean? P of 1 is positive. P of 1 is positive, that means 1 minus A minus B is greater than 0. That means A plus B is less than 1. Is that understood? And P of -1, P of -1 gives me 1 plus A minus B. 1 plus A minus B is positive, implies B minus A is less than 1. So are all the options correct? Oh my God, all the options are correct. Yeah, very good question. I hope you understood this. I hope you understood. This is how you analyze with the graph and everything. Yeah, great, great, great. Okay, extra slides. Okay. Again, please pause the video and try the question. Suppose this equation, a quadratic, has a rational root where a, b, c are integers, not all 0. Which of the following are necessarily true? First of all, if it is rational, that means the discriminant has to be a perfect square. No, discriminant has to be a perfect square of an integer because the discriminant is b square minus 4ac, and we want the root of discriminant to be integer, because we want rational roots. So this has to be an integer, so this has to be p square, right? Now this has to be a perfect set, so option C is definitely correct. Okay. If a rational root exists and a not equal to 0, then this is greater than, obviously, because this is some p square, this is definitely greater than or equal to 0. Okay. Okay, done. So C and D are correct. What about A and B? If one of them is correct, then both are correct. At least one of them is even. If we have a rational root, at least one of them is even. If A, B, C are odd, then the equation has no rational root. Both are equivalent statements. Do you see that? I hope you see that both are equivalent statements. Now, how do we prove that? Again, we have to bring this idea that, let us assume we have to prove that using contradiction for option A and B, using contradiction. Okay, so let's say D equal to B square minus 4AC equal to P square, such that A comma B comma C all are odd. Let us assume they are all odd. So what happens? That means B square minus P square is equal to 4AC. That means B minus P into, oh, first of all, if ABC is odd, this will imply that P is also odd. You see, because this is even, this is odd. So overall it is odd. So this has to be odd. Okay. So B minus P into B plus P equal to 4AC, right? Now, because B and P are odd, this is even. Because B and P are odd, this is also even. So I can assume B minus P is equal to some 2K and B plus P subitum some 2L, right? So this will be 2K into 2L, such that this is 4AC. That will imply K into L. So 4KL equal to 4AC. So basically 4 cancel. KL equals to AC. We have this. And remember, AC are odd. This is odd. Okay, what can we say about K and L? Now, what do we find? 2B is equal to 2K plus 2L. So that will imply B is K plus L and P is L minus K. Now, if this is odd, that means this is odd. Yeah. That will imply K and L have to be odd again. If one of them is even, then the product will be even. No? This is odd implies this is odd. That means K and L are odd. That implies K plus L, this is supposed to be even. And this is also supposed to be even, which is a contradiction. It contradicts the fact that B and P are even. We assumed B and P are even. All are even. This is the assumption. All right. So this contradicts our assumption. Therefore, it is not possible. Hence, A, B, C all cannot be odd. All can't be odd. Right? That means both the options A and B are also correct. Both the questions are brilliant. At least one of A, B, C is even. If A, B, C all are odd, then the equation has no rational root. I hope that is clear. Okay. Now, oh, what happened to this? I don't know why this is happening. Just a minute. Yeah, the question is back. I think still something is missing here. Oh, yeah, there we go. So I don't know why that happens. I have no idea. Okay, we are back. Anyways, we have a quadratic. Pause the video. This is a subjective question, no options. We have a quadratic with real coefficients for which mod of the quadratic is less than or equal to 1 for values of x between 0 and 1. All right, and we have to prove that this is less than 17. So pause the video and obviously try it, but here is my attempt. if I have P of x is equal to ax square plus bx plus c, right? Then P of x, then mod P of x is less than or equal to 1 for all x belongs to both 0, 1 included this interval. That means I can use the midpoint, extreme points. So P of 0 is definitely less than or equal to 1. P of 1 by 2 is less than or equal to 1, and P of 1 is less than or equal to 1. So let us use these. What is P of 0? C. That was easy. P of 1 by 2, a by 4 plus b by 2 plus c. And P of 1 is a plus b plus c. Can we solve for ABC? So C is equal to P of 0. Okay. So A plus B is equal to P of 1 minus P of 2, P of 0. And A by 4 plus B by 2 is equal to P of 1 by 2 minus P of 0. So I have to multiply 2 here, let's say. So I'll multiply 2. And if I subtract, I'll have A by 2 is equal to P of 1 minus 2P of 1 by 2, and this minus this is plus P of 0, right? So A is equal to 2P of 1 minus 4P of 1 by 2 plus 2P of 0. Okay, and hence B will be P of 1 minus P of 0 minus A. So minus 2P of 1 plus 4P of 1 by 2 minus 2P of 0. So what do we have? This is very interesting. So P of 0, P of 0. So 4P of 1 by 2 minus P of 1 minus 3P of 0. Wow. So can we use again? I think I have to again use triangle inequality. So mod C is less than or equal to mod P of 0. So it is actually equal to mod P of 0, which is strictly less than 1, right? Because it is strictly less than 1 for, or not strictly, but less than or equal to. What is mod A? This is less than or equal to 2 mod P of 1 because of triangle inequality, plus 4 mod P of 1 by 2 plus 2 mod P of 0. Okay, great. So this is less than or equal to 2 plus 4 plus 2, which is 8. Similarly, if you see mod P, this is B, right? This is B. Mod B is less than or equal to 4 plus 1 plus 3, which is again 8. So, so mod A plus mod B plus mod C is equal to, is less than or equal to 1 plus 8 plus 8, which is 70. Crazy. So good. Lovely, no? So that's how you solve it, buddy. I hope you understood, na? I have what I did here. Mod A, I just took mod on both sides. Now this is less than or equal to individual mods. I hope you know what triangle inequality is. I'll just revise. Triangle inequality is mod x1 plus x2. It need not be positive or anything. Any n is less than or equal to mod x1 plus mod x2 till mod xn. All right, that's the first subjective question. Now let's do the subjective question 2. Beautiful. With so prove that this equation with an minus 1 a, and you see that the last three coefficients are 1. So first of all, first information I can get from this is no roots is 0. No root is equal to 0. Okay, roots are not 0. Basically, roots non-zero. With all real coefficients, cannot have all of its roots real. So first we assume all of the roots are real. What is the condition if roots are complex? We'll have stuff like, what is complex? I square is equal to -1 here. So it's like if a square thing or sum of squares is less than 1, we don't want that. All right. First of all, here I cannot talk about anything other than the product. Even if I take the product of the roots, let alpha 1, alpha 2 be the roots, alpha n be the roots. Then you see that alpha 1 into alpha 2 into dot 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 till alpha n should be equal to 1 by an. I don't really like this. The leading coefficient is an and we don't know anything about an. So what can we do better? I want to make the leading coefficient 1. So if these are the leading coefficients, can I reverse it? We already used something like that in the previous one. So let's take beta I is equal to 1 by alpha I, and this will be the roots of p of 1 by x into x power n, right? So what is p of 1 by x into x power n? So x power n into an by x power n, an minus 1 by x power n minus 1 till so x cube a3 by x cube 1 by x square 1 by x only plus 1, right? So what is this exactly? This is an plus an minus 1 x plus till a3 x power n minus 3 plus x power n minus 2 plus x power n minus 1 plus x power n. So iska roots, the roots are 1 by alpha 1 dot 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 till 1 by alpha n, which will be beta 1, beta 2, so on till beta n. Okay, fine. Let us assume, and this is possible because none of them is 0. Alpha I is not 0. So this is possible. Okay. Assume all beta i's are real. We want that. Okay, anyways, what is the sum of beta I? Summation of beta I. If you see summation of beta I, that is 1, I think. Minus 1. Okay. What is summation of beta I, beta j, such that I is less than j? That's what, taking 2 at a time, and if we are adding them, this coefficient, this will be the coefficient of x power n minus 1 divided by the coefficient of x power n minus 2 divided by coefficient of x power n. So this will be 1, right? So because this is minus b by a, this is minus plus c by a, these things. Okay. What can we talk about with this using beta I square? So let's not say that. I'll say beta I whole square. Can this be written as summation beta I square plus 2 times summation beta I beta j, I less than j, right? I hope you know the identity. A plus b plus c whole square will also look like this. If you take any number of big powers, you'll get this only. Make sense? So you see that 1 is equal to summation beta I square plus 2 times 1. So this will imply that summation beta I square is equal to 1 minus 2, which is minus 1. Right? Make sense? So now, is this possible? If these are real, real would imply this is always greater than or equal to 0, but this is less than 0. Therefore, beta i's all are not real. That means this will also imply again alpha I is also all are not real. That's it. That's what we needed to prove. Alpha i's are the roots of this equation. So that's it. Proved it. Crazy. So lovely questions, guys. I hope you enjoyed this session. So guys, a quick announcement. If you're interested in this video, most probably you're interested in higher mathematics which is beyond the school syllabus, beyond even the JEE syllabus, right? So if you are such a person who enjoys higher level mathematics, we're bringing a course for you named Target Math. We know that there is full math mastery, but that covers the mathematics in general. But this batch will cover mathematics in a higher level. All right, if you are interested in that, this batch is for you. It will be starting from 21st of July, so hurry up. It's going to start soon. It will be taken by the great Chetan sir. I hope you all know him. Definitely you must be knowing him. Now, who is this batch for? This batch is for class 12 students. It's for droppers. It's for ISI aspirants mainly, CMI aspirants also mainly. Or if you are simply aspiring for JEE and if you want a stronger mathematics, because JEE mathematics may not be that uh, stimulating for a lot of students unless you're doing calculus or something, but this batch will dig deeper into all the topics which are required for mathematics. If you enjoy mathematics, this batch is going to help you. Now, what are the highlights of this batch? There will be more than 95 live sessions, 3 sessions a day, 3 p.m. to 4:30 p.m. again taken by Chetan sir. UGA plus UGB pattern practice tests. So because ISI and CMI require higher level mathematics, and their pattern is in general, that's how they test, and that's why it is so good. You are going to be practicing in their pattern. Assignments every day after the session, Telegram group for discussions after the class, monthly progress report. This is constant in every batch. Now, a free bonus of ISA UGB mastery batch, right? If you're preparing for this, you'll also require preparation for UGB. If you know what UGB is, it is a subjective paper, 8 questions, 2 hours. So that mastery, writing a subjective solution is going to take some practice, and this batch is going to teach you that worth 1,000 rupees you're going to get for free if you take this batch before 21st July. Now, if you want to avail this price, please use the coupon code given below and you can avail it only for 13,000 rupees. And remember, it is 95 plus sessions covering all of mathematics in depth. So, yes, this price is definitely worth it. So, please go check it out. Link will be in the description. Please uh, go check it out. That's it. Take care. Tata. Don't forget the coupon code. Continue with the video.